Right, guys. Good evening.
Hi,
So,
Kranti.
hi. So, yesterday we have discussed topics on sets and bins, and also groups and hierarchies. So, within sets, we have discussed about different ways that we can create sets on, and that we have to create sets on dimensions, and we have seen how we can create combined sets and and later on we have discussed about bins, which can be done on measures, and we have performed few tasks on them, and then we move to groups. So we've seen how we can make groups within dimensions with the members in the dimensions, and we've seen how we can also make visual grouping later. So we have seen about uh, hierarchies, how hierarchies are useful while drilling up, down, and across. So, and we also seen about the differences between sets, bins, and groups. So, those are the topics that we have discussed yesterday. Today, we'll be discussing about different chart types that are available in Tableau. So, basically, if you see all the charts, so we can divide all these into three types, all these charts into three types. So all these different charts in Tableau can be divided into three types. So today we are going to discuss about types of charts or visualizations. So there are three types of charts. So what are those three types? Univariate, bivariate, and multivariate. Okay, so um, there are three types of charts. So univariate charts support univariate analysis. That means um, having one variable or one measure. Okay, so all these univariate charts contain only one measure. So in case of bivariate, so we have uh, two measures in the visualization. So it bivariate type of chart supports bivariate analysis, so which has two measures in it. So in case of multivariate, so it involves more than two or more than two measures. So it supports multivariate analysis. Okay, multivariate analysis, it contains more than two measures. So when it is two measures, it's bivariate analysis, uh, and when it is more than two, it's multivariate analysis. So this type of a chart, multivariate chart, supports multivariate analysis. So we'll see how we can plot graphs using different number of measures in the view. Okay, so first we'll look at the basic chart type. So which is bar chart. Okay, so for a bar chart, so there is an option called show me in Tableau. So when you uh, hover over the visualization, so there are 24 bar uh, chart types that are uh, available in show me. So you can choose from any of these chart types, and once you hover over the visualization, so you'll be able to see the dimensions and measure requirement at the bottom of the view. So I'm hovering over the bar chart now. So here for horizontal bar charts we need zero or more dimensions and one or more measures. So um, so these are the requirements for plotting a bar chart. So these bar charts are used to perform comparative analysis. So if you want to compare things, you use bar charts. So these are used to compare data across multiple categories. So if you want to compare data across multiple categories, you use bar charts. Okay, so there are three types of bar charts in total. So what are those? Horizontal bar chart, stacked bar chart, and side by side bar chart. So there are three types of horizontal bar charts. One is horizontal, second one is stacked bar, and third one is side by side. Okay, so the horizontal bar chart needs only one measure, one or more measure, at least one measure. Okay, so a stacked bar also needs one or more measures. Similarly, for side by side bar, so we need at least one or more measures. So that means all types of bar charts support univariate, bivariate, and multivariate analysis. So if you have one measure, that is univariate. If you have two, that is bivariate. If you have three or more than three, so it is multivariate analysis. So basically bar chart supports uni, bi, and multivariate analysis. Okay, so it is possible to build a bar chart with one measure and without any dimensions. So in this case, horizontal bar chart can be built with one measure and without any dimension also. Okay, so however, for stack bar you need at least one dimension. So for side by side also you need at least one dimension. For horizontal bar, you may not need any dimension. With just a one measure also you can build a horizontal bar chart. Okay, so if you go to horizontal bar chart in detail, in horizontal bar chart, Tableau will display each and every categorical value in a separate bar for comparison. Okay, so um, in any dimension, so dimension is categorical in nature. So that means that the values in the dimension are divided into different blocks or categories. So if you see categories, so there are uh, different members, different values within each dimension. So you basically divide the data into different blocks or categories. Okay, so if you use a horizontal bar chart, Tableau will display each and every categorical value in a separate bar for comparison. So you will get each category, a categorical value as a separate bar like this for comparison. So if you want to compare any data, so horizontal bar chart is a default chart for such type of a comparative analysis. Okay, so while stack bar, in the case of a stack bar, if you group all the categorical values into a single bar, it is known as a stacked bar chart. So if you group all the categorical values into a single bar, so um, in in the case of a stacked bar, all the categorical values stack up one over the other, and they are represented as a single bar like this. Okay, so for example, if you have 10 categorical values within a single dimension, so for example, if continents are if you take an example of continent, so in continent, how many categorical values are there? There are one, two, three, four, five, six categorical values. If you use a stacked bar, So within a single bar, all these six categorical values will will stack upon one over the other, and they will be represented in a single bar like this. Okay. So if you group all the categorical values into a single bar, then it is known as a stacked bar chart. So we have to note here that stacked bar chart will not be effective if the data fields contains huge amount of data. So in the example I have taken only continent having how many categorical values? Only six categorical values. So it is not recommended to take uh, any field which is having large or huge amount of data. So if you have large amount of values, so stacked bar will be uh, very clumsy in nature. So you should not use stacked bar when you have a lot of values within a dimension. Okay. So if you see an example here, so we're basically uh, showing a stacked bar for sales. Okay. So it is showing a lot of data in a single bar. So this is not recommended. So sales values are huge. So we should not use stacked bar for such a huge number of entries within a field. Okay. So we'll design different types of bar charts in Tableau using a task now. So for horizontal bar chart, we'll use continent into rows, profit into columns, and continent into colors. So these are the different members in a continent field. Okay. So we have horizontal horizontal bar chart in the view like this. Okay. You can sort this as well based on the number, based on the profits numbers. So we'll see stacked bar now. So we'll drag sales into rows. Rather than that, we'll um, in stacked bar, we'll see continent, continent into rows. Yeah. So using a stack bar, we can show data like this for continent. So there are how many continents? Six continents, and we are showing sales of this continent. And on a stack bar, we are showing sales of each continent like this. So in a single bar, you can show the sales coming from each continent like this using a stack bar. So we'll go to side by side bar. So in side by side bars, bars are colored with dimensions. So we'll drag customer segment and continent into columns. and profit into rows. We'll go to show me and click on side by side row. So each continent is represented with a different color like this, with a side by side bar graph. Okay, so here uh, we have consumer segment and also continent, um, and showing all the profits. So and each continent is represented by different color like this. So this is a side by side graph. Okay, so you can use you can do by multi and univariate analysis using bar charts like this. So these are the different types of bar charts that you can plot in Tableau. So in Tableau we can plot horizontal bar chart, stacked bar chart, and side by side bar chart like this. And we have a next type of chart called line chart. Okay, so we have line chart in Tableau. So line charts are used to perform time series analysis. So if you want to perform a trend analysis or a time series analysis, so you use line chart. So that is, if you want to compare data over a long period of time, you use line charts. You use line charts when you want to compare data over a period of time. Okay, so there are continuous line charts here. So these continuous line charts is preferable over a discrete line charts. You also have discrete line charts. Okay, so if you want to display each and every time series values, it is recommended to use a continuous line chart. So we have continuous line charts, discrete line charts, and dual lines, uh, dual line charts. Okay, so we have continuous, discrete, and dual line charts. So these are three types of line charts that you can plot in Tableau. So in discrete line charts, so it contains discrete dates. In discrete line charts, it contains discrete dates plus line chart. So it contains discrete dates. So we have to have at least one date field. At the bottom, you can see that a date field is mandatory to plot a line graph, which is a discrete line graph. Okay, and you can have one or more measures, and you may not have any dimension also to plot this discrete line graph. So coming to continuous line graph, it contains continuous dates plus line chart. So date field is mandatory, and at least one measure should be there. So you may or may not have a dimension for continuous line charts. For dual line charts, it contains continuous, discrete and continuous dates, discrete or continuous dates plus dual axis line charts. So we have dual axis line charts. So that means the two line charts are plotted on a dual axis basis, and also you also have either a discrete or a continuous dates. Okay, so that's why we are having two line charts to compare. So on line charts, it is possible to perform all three types of analysis: multi, uni, and bivariate analysis. Okay, so the next task will try to plot line graphs. We'll design a discrete line chart to display year-wise, quarter-wise total sales. Okay, so in our task, we'll design a discrete line chart. Now we'll design a discrete line chart. So we'll drag year and quarter into rows. So year can be plotted from order date. Again, drag drop order date into rows. So you'll get year and quarter, and sales into columns. So Tableau will display discrete line chart like this. Tableau will display discrete line chart like this. So this is a discrete line chart. So we have year wise and quarter wise sales as a discrete line chart. Okay, so wherein you have uh, you have a date field. You have a date field, two date fields, year and quarter, and also uh, a sales measure, one measure which is sales. Okay, so we can also show a continuous line chart. Okay, so for showing year wise and quarter wise total sales, um, so we'll use the same year and quarter in rows and sales in columns. Um, so to get the continuous line chart, we'll just use show me, then click on continuous line chart. So this will create a continuum of the trend or the dates in a continuous fashion rather than a discrete fashion like this. So you'll get a continuous line chart using uh, using show me option here. Okay, right. So these are the different line charts that you have. So we also have the other type of a chart called area chart. Okay, so we have area chart. So area chart is an alternative to line chart. So similar to a line chart, so area chart can also be plotted uh, for showing uh, trend or time series. So 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 area charts are nothing but advanced line charts which perform time series analysis. Okay, so area charts are uh, different type of line charts or advanced line charts which perform time series analysis. Okay, so this area charts indicates all the values with the filled portion from the axis. Okay, so uh, in line charts we are seeing we are seeing the only line from the bottom of the axis. In the case of a filled area chart, so we will be able to see all the filled portion from the axis. So all this area will be filled from bottom till the line. So this area between this axis and the line will be filled and shown in the view like this. Okay, so area charts basically indicate all the values with the filled portion from the axis. Okay, so there are again two types of area charts. So one is discrete area chart and other one is a continuous area chart similar to a line chart. Okay, so in discrete area chart, so it contains discrete dates plus area chart. Okay, so discrete area contains discrete dates and area charts. So you'll be able to see the discrete fields by the visual cue of green field color. So if it is blue in color, that means it's a discrete field. So if it is green, it is continuous field. Okay, so a discrete area chart contains discrete dates plus area chart, whereas in continuous area charts it contains continuous dates plus area chart. Okay, so next task we will design area charts. So we'll design area charts to display year wise and quarter wise total sales in discrete area chart. columns, we are dragging year and quarter, and sales into rows. And then we'll select discrete area chart. So this view is displaying discrete area chart. So this view is displaying as discrete area chart. So we can also convert that into a continuous area chart. Okay, so we can show the same as a continuous area chart. So we'll click on continuous area chart to get the same view in a continuous fashion. Okay, so a continuous area chart will be a continuum from start till end, whereas discrete area chart will be shown separately for each time period, year and quarter, like this. Okay, so you can notice that, so this line chart and area charts are similar in nature. So an area chart is a chart which shows a filled portion from the axis till the line chart. Okay, so these are nothing but an advanced form of a line chart. Okay, right. So again, moving on to the next type of a chart, we have circle charts. We have so we have circle charts. So or packet bubbles. So so this is also alternative to a bar chart. So this is also an alternative way to perform comparative analysis or comparison analysis. So we have circle views and side by side. This circle charts. These circle charts. So these are two circle charts. So these are the alternatives to bar charts. So we can perform comparative analysis using these circle charts as well. Okay, so there are two types of circle views, two types of circle charts. One is um, circle views, and other one is side by side circle circle views. Okay, so there are two types: circle views and side by side circle views. So circle charts will support all the three types of analysis. Uh, as you can see, you have to have one or more measures in it. So it's, and even in side by side circles you have one or more measures. So it supports uni, bi and multivariate analysis. Okay, so now we'll design a circle chart which is similar to a bar chart. We'll use continent, in column, customer segment also, and profit into rows. In show me, we will select, we'll go to show me, and then we'll select circle view. So if you want side by side, you can select also side by side view like this. So as you can see, when I have dragged the relevant fields onto columns and rows, I was able to see bar graphs in the first place, bar charts like this in the first place. So as I've told you, these are the alternatives to bar graphs. We can also show these visualizations as circles like this. Okay, so you can show side by side circles or circle charts like this. So rather than showing the uh, complete bar, you just show the tip of the bar in the form of a circle like this to indicate the height, for comparison. So you can compare different values with a single point rather than complete value from the zero axis. Okay, right. So you have to note that side by side circles and side by side bars will make use of blended axis to compare two or more measures. So uh, if we are using side by side circles or even side by side graphs, so this is side by side graph, right? So when you are using side by side graphs or bar graphs or side by side circles, so Tableau will make use of blended axis to compare two or more measures. So it will make use of blended axis to compare two or more measures. Okay, right. So if you have sales here, you can also show multiple measures into the view like this using side by side graphs. Right. So this is about circle charts. So we also have maps. We also have maps here. So as you can see, there are two types of maps in the Tableau show me option. So maps are used to perform geographical analysis. If you have geodata in your data source, you can use maps to represent the data on a map. So there are two types of maps in Tableau. One is symbol map and other one is field map. Okay, so there is symbol map and the other one is field map. Okay, symbol map should have 0 to 2 measures. Okay, so it supports union bivariate analysis. Okay, a field map should contain at least 0 or 1 measure. So field map supports what type of an analysis? Univariate analysis only. Okay, so that means a field map contains only either a 0 or 1 measure, um, and a symbol map contains either 1 or 2 or 0 measures. Okay, so now we'll try to plot a symbol map and a field map. So first we'll try to design a symbol map to display country wise total sales. So country is a geofield, right? So we'll use country as a geofield to plot the uh, symbol map. So we'll drag country into rows. And then sales into columns. In show me, we'll select symbol map, directly going to show me. So this will display the sales of each country on a map like this. So sales is shown as a size in marks card, and also the country is shown as a detail. So when you hover over that, it will be shown in the tooltip like this. When you hover over each country, so um, the country will be shown as in a tooltip, and also the sales numbers. Okay, so using a symbol map, we can represent geographical data. So what is geo data here? Country is a geo data here. Country or region is the geo data. So using a geo data, so geo data is represented with a globe symbol like this. So for any geo data, we can show that on a map like this. Okay, right. So we'll also see a field map to display country-wise total sales. So this is how a field map looks like, the same data. Okay. So we can also show country into label, show which country it is. Okay. So the darker the shade, the higher the sales. So we have symbol map and also field map like this. These are the two options that you can show geo data in Tableau. Right. So these are the map options in Tableau. Then we have tree maps. So tree maps are a new feature from Tableau 8 in show me option. Okay. So they appear in the form of a rectangular boxes. The data appears in the form of a rectangular boxes like this, and um, this is also on an alternative to a bubble chart. So this is a bubble chart. So this is an alternative to a bubble chart as well. So where is this tree map used? So this is useful to display large amounts of data or information in less amount of space. If you have huge data, so the highest data point would be shown onto the top left corner like this, and the lowest would be shown at the bottom right corner like this. If you want to show a large amount of information, so in a small space, less amount of space, so you'll be using tree maps. So tree map is an alternative visualization for comparative analysis or proportionate analysis. So if you want to compare a large amount of data um, on a single, in a small view like this, so you would be comparing different members in a data in a dimension by using tree maps like this. So tree maps support only union bivariate analysis. As you can see, it supports only one or two measures. So only bivariate and univariate analysis can be done using tree maps. The okay, so these are the alternative maps for bubble charts. So we have to note here that the tree maps will show the information in the form of a rectangular boxes, and the size of the tree map will decrease from left to right. Okay, so the size would be decreasing from left to right. So the highest value uh, member would be on the leftmost part, and the lowest value would be onto the rightmost part, right bottom part. So this is also one of the very important certification questions. So you'll be asked about tree maps like this. So in the size of the tree map will decrease from left to right. So you may be asked what in the tree map, so what would be the size, will it decrease from right to left or left to right? So the answer is left to right. So the size of the tree map will decrease from left to right. Okay, so in the next task we'll plot a tree map, we'll design a tree map for continent wise sales every month. Okay, So we'll drag continent into rows and sales into columns. In show me, we will select Remap. We'll drag month into columns. We'll take order date and then select month. And select entire view. So basically for each month, we are showing a tree map of continent wise sales like this. So if you don't use a month, so you'll get a view like this. So the highest value would be shown onto the left and the smallest value to the right. So Australasia has least amount of sales. Asia has the highest number of sales in the data set. So using tree map, you can show a data like this. Okay. So the next chart type is text text chart or text tables. So text tables, this text charts display all the values in the form of a text only without any graphical visualization. So if you want to show only data in the form of a text or a table, so use this type of a chart. Okay. So there are two types of text tables, two types of text charts. So one is text table, um, which is this, and the other one is highlight table. So there are two types of text charts. One is text table, other one is highlight table. This is next text table is normal table, which is also a cross tab or a pivot table. So if you make data into a pivot or a cross tab, you will get this type of a chart or a normal table or a text table. Uh, and we also have a highlight table, so which highlights the data in the view. Okay. Text table supports this text table supports all the three types of analysis: uni, multi, and bivariate analysis, whereas highlight table supports only univariate analysis. So a highlight table accepts only one measure, as you can see in the view, whereas text table supports one or more measures. So you can perform all three types of analysis using a text table, whereas a highlight table can be performed for only univariate analysis. So we'll design a better chart now. So we design text charts to display continent wise profits. So instead of sales, we'll use profits. We'll also use a customer segment into rows and profits into sum of profits into columns. And go to show me, click on text table. Okay, so this will show a cross tab of consumer segment and continent and the values like this. Okay, it's also a pivot table, also a cross tab. It can also be called as a cross tab or a pivot table. So in Tableau, it is called as a text table. It's called a text table, right? So we can also show this as a highlight table. So basically, it will it will be doing sequential highlighting of the data. So the higher the value, it will show the thicker shade. So the lower the value, it will be show you a paler shade like this. So basically, it will incorporate sequential highlighting of the data points while using highlight table. Okay, right. So we have to note here that highlight table will highlight the highest value in the table with the thicker color, and the lowest value with the lighter color. Lowest value with the lighter color like this. Okay. So this is about the text tables, and we also have bubble charts. Okay. So when you use bubble charts, they are used for contribution analysis. So if you want to see what is the contribution of different members in a group, so in a dimension, so you'll be using uh, a, a bubble chart. So there is also a pie chart here. So pie chart is also used for contribution analysis. Pie chart is also used for contribution analysis. Okay, pie chart is not recommended if the number of slices are more than 12. So if you use the members more than 12, or the slices more than 12, the chart becomes very cluttered in nature. So you should not use a pie chart if the slices are more than 12. Okay. So bubble chart is a new feature. So you also have a bubble chart. So it's a new feature from Tableau 8 version. Okay, in Show Me. Okay, so it is also used to perform a proportionate or contribution analysis if the number of values are large. So if the number of values are large, say in the case of pie chart, so if there are more number of slices than 12, so the chart becomes very cluttered. So instead of a pie chart, use a bubble chart if you have more number of values. Okay. So in those cases, bubble charts will be very effective to represent the data. So a, bubble chart you accepts one or two measures, and a pie chart accepts one or two measures. That is, both pie and bubble chart supports only union bivariate analysis. Okay. So now we'll perform a task to plot these chart types. So we'll drag content into rows and sales into columns. In Show Me, we'll select pie. So you'll get a slices of the data using a pie chart like this. So you can represent the data by selecting the field and showing it in label like this. So if you want to have a container continent also, you can show that in label like this. Okay. Okay. You can have a pie chart view like this. Okay. So we have dragged continent and sales into labels. So we can also show percentage of table by clicking on analysis table and click on percentage of table. So you'll be able to get a percentage like this. Okay, right. So we'll perform a task, similar task, to show a bubble chart. So we'll show country wise, we'll show country wise profits. We'll drag country into rows and profits into columns, and select bubble chart. So, and also we'll show country into color. So the size of the bubble represents the uh, size of the profits. Okay. So the bigger the bubble, the higher the profits. Okay. So this way you can show uh, more number of entries when you cannot represent that in a pie chart. So you can use a bubble chart to show the data. Okay. So you can show the data like this as well using a bubble chart. Right. So we this is about pie and bubble charts. We have scatter plots also. Okay, we have scatter plots. So these scatter plots are used to compare uh, and identify the relationship between two or more measures in the form of a coordinate system, x and y axis. Okay, so uh, you have scatter plots here. So scatter plots is used to compare and identify the relationship between uh, two or more measures in the form of a coordinate system or coordinates or x or y axis. Okay, so as you can see, it supports 2 to 4 measures. So that means it supports bivariate and multivariate analysis. Supports bivariate and multivariate analysis. Okay, so you might have worked on x and y axis coordinate systems, quarter 1, quarter 2, quarter 3, and quarter 4. So similarly, a scatter plot also uh, plots this graph in a similar fashion. So in the form of a coordinate system. So we'll plot a graph to know scatter plot view. So here we'll try to identify the relationship between sales and profits for every customer. Okay, so we'll drag sales into columns, which is x-axis, and profits into rows, which is y-axis. So you're getting a coordinate system like this. So we'll drag customers into detail, customer name into detail. Okay, to get a detailed information of each and every customer. So we have plotted sales on x-axis and profit on y-axis and customer name in detail to get the detailed information of each customer in the scatter plot graph like this. So this is in the form of a coordinate system. Okay. So we have to note here that on detail shelf, we can place multiple fields at a time. We can place multiple fields in detail shelf at a time. Okay. So a detail shelf in the marks card will add the required level of detail to the visualization. So here the required level of detail is customer name, customers. So we have added that detail using detail shelf here. Okay. Also note here that only dimension will add a level of details if you place them into the detail shelf. Okay, so we have to use only dimension into details. So we have to keep that in mind. Okay, so this is about scatter plot. Um, we also have heat map. We also have heat map. So this is the heat map chart. So this is an alternative to tree map. This is an alternative to tree map. This is called as a heat map. So this is an alternative visualization for comparison analysis. Okay, so for comparison analysis, heat map is also an alternative chart. So heat maps display values or numbers in the form of a table or grid, where the larger values will be encoded in the bigger size and smaller values will be encoded in the smaller size. So, so as you can see, heat maps are displaying uh, numbers in the form of a table or a grid format. So we are able to see big blocks and also smaller blocks here. So the bigger the block, that means it is having higher value. So smaller the block indicates it's having the smaller value. Okay, so as you can see at the bottom, it supports one or two measures. That means you can perform univariate and bivariate analysis using a tree map. So we'll perform a task to know heat map. So we'll design a heat map for month-wise profits in each and every continent. We'll drag month into rows using order date. So it will, by default it will be aggregated to year. So we'll change that to month, right now, and profits into columns. We'll show using heat map by selecting it in show me. So we'll drag profits into color to show different profits in different colors. Then we'll drag continent into columns. So to bifurcate the view. We'll keep that we'll keep that in rows so that we can see in this view. So we'll select the entire view. Okay, so this will show uh, the profit values uh, of different continents. So higher the profits, the higher the bigger will be the block. The lower the profits, the lower will be the smaller will be the block. So using a heat map, we can also represent a large amount of data in a compact space like this. Okay. Okay. So we have we have box plot also here. So box or whisker plot in the view. So we'll we'll try to understand this box and whisker plot in detail, because this is one of the important chart types that you will be using in our real-time basis. So we'll take a quick break of 2 minutes and we'll come back again, and then we'll try to understand this box and whisker plot better. Okay, see you after 2 minutes, guys. Right, guys. So we're now looking at box plot or whisker plot. Okay, this is box and whisker plot. So whisker is nothing but line. Okay, first and last line, or a maximum or minimum line. You can, as you can see in the view, if you show a distribution of data using box and whisker plot, you have maximum and minimum lines. Okay, so these are called whiskers or lines, or the first or last line. So this is the first line, this is the last line. So these are called whiskers or lines, or first line or maximum line or last line or minimum line. Okay, so this is a form of a statistical visualization that you use typically. uh, Basically it is mainly used in statistics. So it is used to identify distribution of values. So if you want to identify the distribution of values in a data set, you use box and whisker plot. Okay, it is also called as box plot, and sometimes it's called as box and whisker plot. So we'll first try to plot this graph and try to understand each component of it in detail. Okay, first in this task we'll try to plot this graph. So we'll design box plot for continent wise total sales. So we'll drag continent into columns and sales into rows. We'll click on show me, then select box and whisker plot. Okay, so we'll swap the axis. Right. So these are the whiskers, the maximum and minimum lines. Okay. So this is the lower whisker, and this is the higher whisker. This is the upper whisker. Okay. This is a lower whisker and this is the upper whisker. So this is called the lower quartile or lower hinge or lower quartile, and this is called upper quartile. So this line here is called upper hinge or lower upper hinge or lower upper quartile. So this is also called as Q3. So this lower hinge or lower quartile is called quarter 1 Q1, and this upper quartile or upper hinge is called as Q3 Q3, and there will be medium in somewhere here in between. So this median is called as Q2. So Q1 is lower quartile, Q2 is median. So median value is visible when you hover over the view. It is called Q2, and the upper quartile is called as Q3 here. This line is called Q3, upper quartile or upper hinge line. So it is also called as hinge or quartile. Okay, so we'll try to understand uh, these values better by plotting a chart. right? So this is lower whisker, and this is higher whisker. And this is called Q1, which is nothing but lower quartile. Or hinge. And this is called Q2, which is median. And this is Q3, is upper quartile. Upper quartile, or it's also called as upper hinge. This is first part. This area from here to here is second part. No, the median between this part and this part. This is second part. This is the center area between Q2 and Q3 is third part. This is fourth part. Yeah, this is fourth part. Okay, so here in box plots, Tableau indicates 50% of the values in the form of a box and 50% of the values in the form of a whisker or a line. Okay, so 50% it indicates in the form of a block box, and the other 50 in the form of a line like this. Okay, so you can see that in the view also like this. Right. So in box plots, Tableau indicates lowest and highest values in the form of lines, which are known as lower and higher whiskers. So the lowest values and highest values in the distribution of data will be indicated with lines. The lowest line is known as a lower whisker, and the highest value or highest line is known as higher whisker like this. Okay. Then Tableau finds the median, which is known as Q2. So median from where? So from lower whisker to higher whisker, it finds out the median. It is called as Q2. Okay, it is known as Q2. Median is known as Q2. So after finding the median, again it finds the median in between lower whisker and median. So it finds out the uh, median between lower whisker and the median. So it finds out the median between lower whisker and the median. Okay, which is known as a lower quartile or lower hinge. So Q1 or Q1. So which will be indicated with Q1. So Q1 is the median between lower whisker and the median. Okay, it is indicated by Q1. It is known as lower quartile or lower hinge. Okay, again it finds the median between Q2 and higher whisker. It finds out the median between Q2 and higher whisker. So this is called as, this is indicated with Q3, which is known as the upper quartile or upper hinge. Okay. So, so Q2 would be shaded in one color and Q3 will be shaded in another color. Yeah, Q2 will be shaded in one color and Q3 in another color. So the value in between Q3 and Q1, the value in between Q3 and Q1 is known as the interquartile range or IQR. This area between Q1 and Q3, this is known as interquartile range or simply IQR. This is nothing but the area between Q1 and Q3. Q1 to Q3. Okay. So this is box and whisker plot. So we need to understand these concepts better to understand the uh, chart box and whisker plot like this. So you can again divide this into customer segments as well, so that you can view different parts of a of box and whisker plot like this. So basically you can see the distribution of data using box and whisker plots. Basically it's a statistical analysis technique. So it's a statistical type of a visualization in Tableau. Okay, right. This is about box and whisker plot. So yeah, we also have dual combination chart here. So combination charts are possible directly from show me option with the help of dual combination chart. So we can plot a bar graph and a line chart in a single view using dual combination charts like this in using show me. So we'll try to plot a graph like this. We'll design a dual combination chart for year-wise sales and profits. We'll drag year into columns using order date. And sales and profits into rows. We'll click on show me and select dual combination chart. It will automatically show uh, two charts in a single visualization. So sales in line and profits in bar like this. Okay, right. This is about dual combination chart. So we have also bullet graphs. Okay, bullet graphs. So this is a new option in show me from Tableau version 8. Okay, so this is used to compare actual values with the targeted values. Okay, so we can compare uh, a, a benchmark value or an actual value with the targeted value. Okay, so you can use a benchmark and then compare that benchmark values with the rest of all the actual values, or you can take a target as one value, and you can compare the target value with the actual values, or you can compare the actual values with the target values. Either way is fine. So as you can see at the bottom, it supports only two measures. That means using a bullet graph, you can only do bivariate analysis. Okay, so we'll try to build a design a bullet graph for continent wise sales and profits. So we'll write continent into columns, sales and profits into rows. We'll go to show me and select bullet graph. So you have to note here that only when these conditions are met. So for each chart type, there are different requirements. So for example, in bullet graph, it should have uh, a minimum of two measures or zero or more dimensions. Okay, for few graphs, you should have date field. Like area charts, you should have compulsory a date field. So it's a mandatory field, one date field. So like that. So when you drag these fields, the relevant fields into columns and rows, and also these marks cards only, you will be able to see that chart type. So you're seeing few of the charts in highlighted mode and few not in highlighted mode. Some are disabled in nature. That means, so the conditions or the requirements of those charts are not being met by dragging in the view. So those fields are not there in the view. So if you hover over the chart type, you will see the conditions. So that means, mm, you're not have for getting area chart, one date field is mandatory. So if you drag one date field into the view, you will also get area chart as a highlighted option here. So so here in we'll now try to build a bullet graph. So we have coordinate in columns and sales and profits in rows. So we'll directly go to show me and then click on bullet graphs. So this will create bullet graph like this. Okay, so basically, so uh, we have two values to compare with: average sales and sales of different uh, continents. So we'll be comparing like this. So we'll also perform one more task to understand this better. So we'll drag continent into, so we will use coffee chain data now. So, so we'll go to, we'll connect to coffee chain data, and then we'll compare state-wise profits and budget profits using bullet graph. We'll first connect to coffee chain data. Use coffee chain query table. Right. So we'll drag state into rows. And then budget profit into columns. we go to show me and select bullet graphs. So here we are comparing uh, one profit value with the rest of all the values for different states. Okay, so this, the budget profit is 28,380 and the the profit values are 31,785. So like this we can compare two measures, one keeping as target and other as actual values. Okay, right. So using this view we can see that whether the target is met or not. Okay, so here the target isn't met, here the target isn't met, but in the case of Connecticut state the target has been met. Okay, so these are all the values: Ohio, Oklahoma. So these are the states where the targets have been met. Whereas in California, the target hasn't been met. So using a bullet graph, you can compare this the values like this. Okay. So this is about bullet graph. So this scatter plot is also known as quadrant chart. So we call the scatter plot also as a quadrant chart. So as discussed, it is used to identify the relationship uh, between any two measures. For example, sales and profits. Okay, so they will be indicated in this in the quadrant names by sales and profits. So we'll try to plot one more graph in as a scatter plot. So we'll drag sales into rows. We'll go to training superstore. We'll drag sales into rows and profit into columns. An item into detail of the marks card. So this will give you a view like this of each item shown on X and Y axis, which is sales and profits. Now we'll create a calculated field with the name quadrant label. So we'll use a condition like we'll first try to uh, check the sales values if they are greater than 0, the profit value greater than 0, then quarter 1. So because all the positive values will be in quarter 1, so we'll check sum of sales which is greater than 0 and sum of profits is greater than 0, then quarter 1. Else if so the quarter 2 will have, so basically uh, the quadrant the quadrant will in first quarter it will have all positive numbers, in second quarter, so x-axis will be negative and y-axis will be positive. Okay. So as, if you see a quadrant, so it looks like this. So this is x-axis, this is y-axis. In Q1, we will have positive x and positive y. So this is negative x-axis. This is negative y-axis. So in Q2, we have negative x and positive y. In Q3, we'll have negative x and negative y. In Q4, we have positive x and negative y, right? So this is how a quadrant looks like, right? So so the, this is the quadrant view. So here I'm trying to do the same using a calculation. Okay. So in the calculation, so in the first quadrant, both x and y axis. So here uh, profit is x axis and sales is y axis. Okay. So profit is x axis and sales is y axis. So in first quadrant we have both x and y axis as positive. So both x and y should be, sales and profit should be greater than 0. Similarly for quarter 2, so sum of sales should be greater than 0 and sum of profit should be less than 0. This is because x-axis is negative and y-axis is positive. So x-axis should be negative. So profit should be negative and y-axis should be positive. Y-axis should be positive. So y-axis is sales. So sales is positive here. So then it is Q2. So in Q3, we have sales as negative and profit as negative because both x and y axes are negative in Q3. You can write else Q4 because this is the last option. Click on OK. So a quadrant label calculated field has been created like this. So we'll drag quadrant label and drop it into label of marks card. Okay. So we have to note here in a scatter plot, all the values will appear in small circles known as scatters. So these small circles are known as scatters. Okay. So like this, you can show the view in different quarters using a scatter plot. Okay. So this is about the scatter plot. and we also have one more view called histogram. So in statistics, bar charts are known as histogram. In statistics, bar charts are known as histograms. Histograms are similar to bar charts. Bar and histograms are similar in nature. However, histogram performs distribution analysis. So histogram performs distribution analysis um, in statistics. Okay, so histogram performs only univariate analysis because, as you can see, it only accepts one measure. Okay, so we also have Gantt chart. We also have Gantt chart here. So these are all simple simple lines that we can you represent the data in. So it should have a minimum of one date field, and 0 to 2 measures. So univariate and bivariate analysis is possible. So or one or more dimensions. So using a Gantt chart, if you want to represent the data on a time period and the performance of different people, if for example, so you can use a Gantt chart and plot the graph. Okay, so these are the different types of charts that are available in Tableau using show me option. So 3, 1, 2, 3, 4, 5, 6, 7, 8. So it is a 24 chart types. So these are the 24 chart types available in Tableau using show me option. Okay, right. So these are the chart types available in Tableau. So now, so we'll try to understand calculated fields. So which is the most important topic in Tableau. So we'll first try to understand calculated fields. Okay. So when we think about
Kranti, your voice is kind of breaking a little bit.
okay, let me readjust.
Cable.
Right. Am I audible clearly now?
Yeah, you are.
Right. So any questions till now?
No, I'm good, Kranti.
Right. So we'll first now look into calculated fields. Okay. So the purpose of this section is to understand the intricacies of manipulating data within Tableau using calculated fields and table calculations. So we have uh, two sections in this calculated fields and table calculations. So in Tableau, we can do a lot of analysis using the already existing fields. So um, we can manipulate the data using calculated fields like this. So in Tableau, we have uh, we can create a calculated field using a calculated field window. So we'll look into these calculated field window in detail. So while coming to calculations, so it is not possible to perform complete analysis every time with the existing data fields. So these are the existing data fields. So in Tableau, it is not possible to perform the required analysis or the complete analysis using only the existing data fields. So in those scenarios, we will have to perform extra analysis by using calculated fields. Sometimes we need to create new fields known as calculated fields based on the existing fields. Okay, so we will use the existing fields and make our own calculations, then use them in our analysis. So we use calculated fields for making that type of an analysis. Okay, so we'll go to the drop down icon just beside dimensions here and click on calculated field. So this will open us a window like this for creating a calculated field. Okay, so calculated fields in Tableau contain four four things basically. So we have functions. So these are all different types of functions which are available in Tableau: number functions, string functions, date functions, type conversion functions, logical functions, aggregate functions, user functions, and table calculation functions. We'll look into each in detail. Okay, these are the functions available in Tableau. Tableau calculated fields. You can use these functions and then make our own calculations. Okay, so we also have fields. So we have to make use of fields. So what are fields? So sales is a field. Sales is a field coming from the data window. It's a field, right? So basically calculated field contains functions. So if you aggregate this field, so using sum is a function here, right? Sum is a function, and sales is a field. So we have functions, we have fields, we also have parameters. So if you create a parameter, we can refer that parameter into calculation as well. So for example, I've created a parameter. So parameter can also be uh, referred into the calculation using case statement like this. Okay, so a parameter can also be referred into a calculation. We It also contains comments. So if you want to comment anything, you can write comments in the calculation window as well. So there are four components. What are those? Functions, fields, parameters, and comments. Okay, we have to note here that in Tableau calculation window, uh, while we are uh, writing any character, so Tableau automatically displays matching field. For example, if I write pro, so it will display automatically the matching fields. So you can so I want the the thing that I want to type is profit, so that is in my mind. So Tableau suggests some of the matches which are already existing. Okay, you can choose from the drop down list whatever you want. So I wanted the profit field. So Tableau suggests different options to choose from. Okay, so what does it display? It displays, as you can see, it displays fields. Profit is a field, right? It displays fields. It also displays functions. Okay, functions are also displayed. As you can see here, functions are also displayed. So these are all the functions based on the options that you have typed in. So these are all the fields, and also it also displays parameters. Okay, if there are any parameters matching the uh, matching the text that you have displayed, so it also, see, parameter 1 is a parameter. So it displays fields, matching functions, and matching parameters. Okay, this this feature is known as auto formula completion. So this feature is known as auto formula completion. Okay, so we have to also note that while writing calculation formula, Tableau will display functions in blue color. Okay, so as you can see here, Tableau displays functions in blue color. So this is the visual cue. All the functions are always displayed in blue color. So fields in orange color. So sales is a field, right? So it is displayed as orange color. So if you see an orange color entry, so that indicates that it is a field. When it is in blue, it is a function. And uh, when you see any text in violet color, then it is a parameter. So parameters are indicated with violet color. When you see comments, they are shown in gray color. Okay, so these are some visual cues while writing formula in Tableau. So blue indicated by uh, uh, all the functions indicated by blue, um, uh, the fields by orange, parameter by violet, and gray comments. Okay, Right. So basically this formula editor, this area is called as a formula editor. So this is a built-in coloring and validation feature. So this is basically used to avoid any syntax errors also. So whenever you write any formula, so this automatically validates the formula as well. So if I write if condition, write any condition, so Tableau actually validates the function. So if I write any syntax error, so it will validate. So cannot mix aggregate and non-aggregate comparisons or result in if expressions. So like that, so you will be able to see if the formula that you have written is correct or not. So now the calculation is valid. So this is also a validator. Okay, it is built-in validation option is also feature is also there. So this formula editor has a built-in validator to avoid any syntax errors. So as you write the formula, syntax errors are underlined with the red squiggly line. So if you write any syntax error, so these syntax errors will be underlined with the red squiggly line like this. Okay, so you can hover over the error line to see directions for fixing it. Okay, so when the errors are there, you will be seeing a red error indicator here. So when you have corrected all the errors, then you'll be able to see you will be able to see a gray option saying the calculation is valid here like this. Okay, this is displayed as the calculation is valid with in gray color. Right. So the fields are all also always indicated fields always indicated within square brackets. Okay, so in orange color they will be indicated within a square brackets. And it is not case sensitive, so upper and lower cases are ignored here for field names. So except for field names, so all the see if you write some in uppercase or lowercase, it accepts, so it's not a case sensitive. However, so the field names should be in the same case. So however, you'll be able to see suggestions based on the options. So if you write S, so you'll be able to see sales as different option. But if you write sales like this, there will be an error. Okay, the same case should be used as it is there in the fields. So sales here is having capital S. So even the text that are using in a formula should also have capital S to it. So apart from field, rest of all can be used in any case. So some can be used as small case or capital case. That's not an issue at all. Okay. So right, first we need to understand where this calculation occurs. Okay. So first we'll try to understand where this calculation occurs. So when you create a calculated field, so Tableau generates query and sends it to database. So a calculated field, when you generate it, so Tableau generates a query based on the calculated field and sends that query to the database. So um, all the calculations with the exception of table calculations which are passed to the database. Okay, so table calculations are performed differently. So we'll confine ourselves with first with calculated fields. Okay, so first those queries are sent to the database. So then the databases processes the query. um, After getting the query from Tableau, the database processes that query, and then the database returns the filtered aggregated rows of data, including new calculated columns. So basically, a new column will be created using a calculated field by querying the database. So the database returns the resultant set by creating a new column creating a new column. Also, you can see in the view that when you create a calculated field, so quadrant label is a calculated field that we have created. So a new field has been created, a new column or new field has been created in the database, data source. So using a calculated field, a new column is created. Whereas table calculations, in terms of table calculations, Tableau performs local processes including the table calculations. So example, percentage of total. If you want to perform percentage of total, um, you can perform that using table calculations. So rather than rather than querying the query to database, so table calculations are processed locally, and then the results will be rendered in the visualization. Okay, they'll be shown in the visualization. So we'll come back to table calculations when we discuss about them. So we'll confine our discussion with calculated fields now. So this is the underlying mechanism how a calculated field functions. So when you create a new calculated field, Tableau generates query and sends to database, and database queries the processes the query and then creates a new column in the data source. Okay, right. So we'll try to create a calculated field. Will in this task we'll display item wise price before discount, discount price, and price after discount. So we'll create three calculated fields. Okay, so the first name is price before discount, price PBD, price before discount. So this is nothing but unit price. Unit price is price before discount, and we have discount price. So we'll indicate with DP, discount price. So the formula is um, PBD, so price before discount into discount. Discount is a field in data source. So this is discounted price, which is price unit price into price before discount into discount is discounted price. And we'll create one more field called price after discount. Price after discount. So price after discount is price before discount minus discounted price. It is PBD minus discounted price. Price before discount minus discounted price. This is price after discount. So we'll drag item into rows, PBD, DP and PAD into columns. Price before discount, discounted price, and price after discount. So we'll right click on PBD, DP and PAD, and in default properties, we'll go to this PBD, we'll right click on default properties, and in number format, we'll go to custom number, and then enter 2 decimals. We'll sort this and click on text. See, this is a text field. So this is the price before discount. Discount is around 5,000, and after discount, so you'll get 90,000 as price after discount. So using calculated fields, you can perform analysis like this. So this is a simple example where you can use calculated fields. Okay. So we will discuss all the different functions that are available in Tableau. Right. So we'll first look at number functions. So the first one is ABS. ABS. So ABS stands for absolute value function. Okay, ABS stands for absolute value function. It takes the input as number. It always takes the input as number. As you can see in the syntax, it is ABS in brackets number. Okay, it ignores the sign of the number and it gives the value. Okay, it always ignores the sign. So if you take -7, it will give you the value as 7. Okay, so the syntax is ABS of number. So if you take ABS of -5, it will give the result as 5. So we'll have to show it as dimension. Sorry, we have to show it as dimension. So the value is, so we have to show it as a text here. Yeah. So it is 5. So even if you take minus, it will show 5. So a 5 also returns 5 here in the calculation. So it will take an absolute value. So even if you create one more field, calculated field with -5 and 5, so it will return 10 in all the cases. So we have to drag that into rows. Okay, and right click on this ABS function and click on dimension. Okay, and make it as a discrete value. So ABS is 10. So the calculation here is, so basically, yeah, whether you take a negative or a positive number, it always converts it into a positive number using ABS function. Okay. So this is about ABS. So we'll discuss about more functions in tomorrow's class. Okay. Any questions?
No,
Yeah,
I'm
if
good,
there are any
Kranti.
questions, yeah,
No any
yeah.
questions.
So yeah, so we'll discuss all the rest of the functions in tomorrow's class. So we'll discuss about all these different types, and so that you can perform all the functions by your end. Okay. Bye. Thank you.